welcome to our today's chemistry lesson, and then in our lesson for today we'll be discussing bonding. So in the previous videos we had discussed on how to determine, or rather write, the electron configuration for all the atoms that we have on our periodic table, and also we had discussed on how to write the chemical formulas for all the compounds that are formed when these atoms on the periodic table here react. So now in our lesson for today, we'll be talking about bonding, and specifically we'll be talking about ionic bonding. So now, we know to say atoms on the periodic table that you are seeing here, they are not stable. And then these noble gases here, or rather the inert gases that are in group 8 or group 0, those are the only elements on the periodic table that are very much stable, and they don't need to react with any other element. So now these other elements, they need to react with each other in order for them to be stable. So these atoms, they react and form bonds in order for them to be to be stable. Ionic bonding, basically, this is a type of bonding that involves the losing and the gaining of electrons. So we are saying this bonding involves losing and gaining of electrons. What do we mean when we say losing and gaining of electrons? We know to say this periodic table, when you look at it, like we discussed in the previous video, from boron, they are going down like that. We know to say the elements this side are metals, and the elements that side are non-metals. So now we know to say metals lose electrons when they react, and then non-metals, they gain electrons when they react. So meaning, in other terms here, we can say it involves metals and non-metals. And then we know to say by nature metals are cations, and then non-metals are anions. If we have to follow ions, meaning these metals are cations, meaning they form positive charges when they react. But for anions, we know to say they form negative charges when they react, meaning metals are given, and then non-metals, which are anions, they are receiving. So we can pick an example of a compound that is formed when a metal and the non-metal react. So for example, we can say what is going to happen when sodium and chlorine react. We know to say, to write the chemical formula there, sodium is in group 1, meaning the valence is 1. Chlorine is in group 7, meaning the valence is 1. If you cross multiply, we are going to get sodium chloride. So this simply means that you are having one atom of sodium and one atom of chlorine. These ones, they are coming together in order for them to form a bond. But what is going to happen here, we know to say sodium is a metal and chlorine is a non-metal. So meaning sodium is going to lose electrons to chlorine. Then chlorine is going to receive electrons from sodium. So if we write them here as neutral atoms, our sodium here and our chlorine there, we know to say sodium is going to have an electron configuration of 2, 8, 1. Why? Because sodium has got 11 protons and it is in group 1. So there we know to say it has 3 shells, meaning it's in period 3. Then it has got 1 electron in the outermost shell, meaning it is a metal in group 1. But what of chlorine? Chlorine, we know to say it is going to have an electron configuration of 2, 87. Why? Because chlorine has got 17 protons as a neutral atom. It has got also 3 shells, meaning it's in period 3, and it has got 7 electrons in the outermost shell, meaning it is a non-metal in the group 7. So now, what is going to happen here? In order for this sodium to be stable, it needs to lose its outermost shell, which contains 1 electron. So meaning when it loses, it is going to give it away. So meaning the sodium is going to lose an electron in order for it to be stable. So when it loses an electron, it becomes a what? Monovalent cation, meaning it is giving away 1 electron. And then now when it gives away 1 electron, what will be its electronic configuration? So since it has given away 1 electron, meaning 1 energy level has gone, or rather 1 shell has gone. So meaning it is remaining with 2, 8, meaning it has remained with 10 electrons, because previously as a neutral atom it had 11 protons, but now it has given away 1, meaning it is remaining now with what? 10, meaning the electron configuration there is going to be 2 and 8. But now Mr. Chlorine here, chlorine is now going to gain an electron. So now when it gains an electron, it is going to be a chlorine ion, which is going to be a monovalent anion, because it is only receiving 1 electron in order for it to be what? To be stable. So meaning the electron configuration for chlorine ion now is going to be 2, 8, 8. So meaning it has moved from 17 electrons to what? 18 electrons. Why? Because it has received an electron. So now let's show how these 2 elements are going to come together. So meaning if we look at this sodium ion, it's going to look like this. This is sodium ion. It has got 2 shells, so it is going to be 1, 2. The first shell is going to have 2 electrons. Then the second shell is going to have 8 electrons. So 1, 2, 3, 4, 5, 6, 7, 8. So meaning this is how our sodium ion is going to look. Not forgetting the charge there to say it has given away 1 electron. But now what about chlorine? Chlorine here now is going to have 3 shells. So a chlorine ion there is going to have 3 shells, which is 1, 2, and 3. So now the first shell is going to have 2 electrons, so we are going to have 1, 2. The second shell will have 8, so we are going to have 1, 2, 3, 4, 5, 6, 7, 8. The third shell also is going to have 8 electrons, so we are going to have 1, 2, 3, 4, 5, 6, 7. But the 8th electron is the electron that it has received from what? Sodium. So meaning that one is going to be written, or rather indicated like that. Meaning this is how the ion for chlorine is going to look like. Not forgetting the charge, which is negative, meaning it has received an electron from what? From sodium. So basically this is how we can express the bonding that is between sodium and chlorine to form sodium chloride. So now, what of if we are given magnesium and fluorine, for example? So here we know to say magnesium is a metal in what? Group 2, so the valence there is 2. Then fluorine is also a non-metal in group 7, meaning the valence there is what? 1. So if we cross multiply these two, we are going to get, the first letter should always be capital. So we are going to get magnesium fluoride, like that. What does this symbolize? This one tells us to say we are having one atom of what? Magnesium, and then we are having two atoms of what? Fluorine. So now, to understand what we are talking about here is that this magnesium is going to give each fluorine an electron, because we know to say this magnesium is a metal from what? Group 2. So meaning it has got 2 electrons in the outermost shell, meaning it is giving away 2 electrons. So in order for it to be stable, it is going to share 1 electron to fluorine, because fluorine only needs 1 electron in order for it to be stable. But in this case, we are having 2 atoms of what? Fluorine. So meaning this magnesium will lose 2 electrons, giving 1 to the first fluorine, and then the second one to the second fluorine. So now let's put this on diagrams here. We know to say, as a neutral atom, magnesium has got 12 electrons, and fluorine as a neutral atom, it has got 9 electrons. So now to write the electron configuration for these neutral atoms, we are going to say magnesium, which is going to have an electron configuration of 2, 8, 2. That's a neutral atom for magnesium. But now, in order for this magnesium to be stable, it needs to lose how many electrons? 2 electrons. So this magnesium is going to give away 2 electrons in order for it to form a magnesium ion. So meaning this magnesium ion that it has formed, it is a divalent cation ion. This simply means it is losing how many electrons? 2 electrons there. So meaning the electron configuration for this magnesium ion that has been formed here is going to be magnesium, which is now going to be 2, 8. Because as a neutral atom, it has got 12 electrons, but out of these 12 electrons, we have given away 2 electrons, meaning it is remaining with how many electrons? 10 electrons. So these are the 10 electrons. 2 plus 8, we are getting 10 electrons. But now, if we come to fluorine, as a neutral atom, this fluorine is going to have how many electrons? 9. So to write the electron configuration there, it is going to be 2, then 7. So meaning in order for it to be stable, it only needs to receive 1 electron. This fluorine receives an electron. It is going to become a fluorine ion, which is a monovalent anion, meaning it is only receiving 1 electron. So when you write the electron configuration for this fluorine, it is going to be 2 and 8. So now let's put them together now as diagrams. We know to say this one, the one that is losing to 2 atoms of what? Fluorine. We are going to put it on the mean. Then these 2 fluorines to which it is giving electrons, we are going to put them on the sides. So this one, the major one that is losing, we're going to put it on the middle there, which is magnesium. We start with the nucleus as usual. It is going to have how many shells? 2 shells. So it's going to have 1 and 2 shells like that. So meaning there, we are going to have in the first shell, we have 2 electrons, like that. In the second shell, we have 8. So that is 1, 2, 3, 4, 5, 6, 7, 8. Then we are going to put the brackets like that. So basically, this is how the structure for magnesium ion is going to look. Not forgetting the charge, meaning it is losing how many electrons? 2 electrons. But now when it loses electrons, since we are having 2 fluorines, the first fluorine will be here, also with 2 shells. So the first fluorine will be there with 2 shells, 1, and the second one. Meaning the first shell is going to have 2, 1, 2. The second shell will have 8, 1, 2, 3, 4, 5, 6, 7. But it has received the 80th electron, it is just receiving from what? Magnesium. So we are going to indicate it like that there. Then we are going to put the what? The brackets like so. Not forgetting the charge, it is receiving 1 electron. Then this other fluorine also we are going to put it on this other side, where we are going to have, this is the nucleus for fluorine, also with 2 shells and 2. So meaning the first shell is having 2 electrons as usual, 1, 2. The second shell is having 8 electrons. So this is 1, 2, 3, 4, 5, 6, 7. But the 80th electron, it is just receiving from what? Magnesium. So we are going to put it there like that. And then we are going to put the brackets like so. And also not forgetting the what? The charge. Meaning it is receiving 1 electron from what? Magnesium. So meaning this one is going to be magnesium fluoride. Meaning here our magnesium is losing 2 electrons. It is giving 1 to the first fluorine and then the second one to the second fluorine. Why? Because if we write the formula here, it is giving us 2 atoms of fluorine and 1 atom of magnesium. So basically, that's how you write or rather express the bonding that is there between metals and non-metals that involves the gaining and the losing of electrons. But now, in most of the questions, they might even ask you about the characteristics or rather the properties of these ionic bonds. So we know to say these ionic bonds, they are good conductors of what? Electricity in molten state. So when they are in aqueous state, they conduct electricity. And then we know to say these ionic bonds or ionic compounds, they are soluble in water, but they are insoluble in what? Organic solvents such as petrol and paraffin and whatnot. These ones, they are insoluble. And then we also know to say they contain metals and what? Non-metals. Not only that, they have a strong force of attraction between them, which makes them to have a high boiling and also a high melting point. So all those are the properties for these ionic bonds that are formed when a metal and a non-metal come together.